Hey everyone. So today we'll be solving the problems similar to homework 5 on ENEE 381. So the first problem is a very transparent crystal reflects 10.56% of the incident red light at normal incidence. What is the index of refraction of this crystal? What could this crystal be? So we'll start with a simple diagram, or let's just mark if this is the dividing line, then let's call this N1 and this N2. Let N1 and N2 be the indices of the two mediums. So let us say N1 is the medium air or vacuum, N2 is the unknown medium. Okay, so now we know that when we are talking in terms of either electric waves or the magnetic waves, we know that reflection coefficient is defined as eta 2 minus eta 1 divided by eta 2 plus eta 1. Sorry, so eta 1. So this is the reflection coefficient when we are talking in terms of electric waves or magnetic waves. How also the reflection coefficient, the power reflection coefficient R, when we're talking about an electromagnetic wave, is given by gamma square, which is equal to eta 2 minus eta 1 divided by eta 2 plus eta 1 whole square. This is the equation when we are talking about uh, power reflection coefficient. Now we are talking here about, in the problem, red light at normal incidence. So red light is an electromagnetic wave, so we have to look at it in terms of power, and that is the reason we have to use the reflection coefficient, which is R. Okay, so we have to use this formula. Now how do we go from here to a point where we find the refractive index of the crystal? So let's start writing what eta 2 and eta 1 are. We know that eta naught by definition is mu naught by epsilon naught, which is the impedance of free space, right? We know this. How do we find the refractive index from this? So let's start making the substitution. Eta 2 is equal to mu 2 by epsilon 2. Eta 1 is equals to mu 1 by epsilon 1. Now we know that mu 1 is equals to mu 2 is equals to mu naught. We make this assumption because this is a non-magnetic medium. Generally, mu does not change between mediums unless otherwise specified. Okay, so what changes is the epsilon 1 and epsilon 2. So now eta 2 is equals to mu naught by epsilon 2, and eta 1 is equals to square root of mu naught by epsilon 1. Now let's make this substitution in R, which will be square root of mu naught by epsilon 2 minus square root of mu naught by epsilon 1 divided by square root of mu naught by epsilon 2 plus square root of mu naught by epsilon 1 whole to the power of 2. Now if we simplify this and write down after all the LCM, taking the LCM and stuff, it will look like mu naught epsilon 1 minus mu naught epsilon 2, so all under square roots, and in the denominator again mu naught epsilon 1 and mu naught epsilon 2. Okay, all square roots here, so to the power of 2. Now what do we know about refractive index? We know that refractive index n is given by C. Refractive index is given by n is equals to C multiplied with square root of mu epsilon. Okay, so if that means N1 is equals to C square root of mu1 epsilon 1, N2 is equals to C square root of mu2 epsilon 2. We know that mu1 is equals to mu2 is equals to mu naught. So therefore N1 becomes C square root of mu naught epsilon 1 and N2 becomes C square root of mu naught epsilon 2. Now let's rewrite R from the expression obtained earlier, and now let's multiply both the numerator and denominator with C square so that we can write the R in terms of refractive indices. Will this look like? If it goes inside, it will be C square root of mu naught epsilon 1 minus C square root of mu naught epsilon 2 divided by C square root of mu naught epsilon 1 plus C square root of mu naught epsilon 2 whole square. We can write this as N1 minus N2 divided by N1 plus N2 whole square. Okay, so now we have an expression for R in terms of N1 minus N2 divided by N1 plus N2 whole square. Okay, so what we are given is that R is equal to 10.56%, or that could be 0.1056. Let's make that substitution. 0.1056 is equals to N1 n minus N2 by N1 plus N2 whole square. We know that N1 is equals to 1 because it is air or vacuum. Okay, now therefore that implies let's make the substitution for N. So 1 minus N2 divided by 1 plus N2 whole square is equals to 0.1056. Now 1 minus N2 divided by 1 plus N2 is equals to square root of 0.1056. Let's find the value of square root of 0.1056. Square root of 0.1056 is equals to plus or minus 0.324. Now both of these values are possible mathematically, but we have to see which of them is actually feasible physically. So we have N2 is either equal to 0.510 or 1.958. Now there are no solid crystals with a refractive index which is less than 1, so N2 cannot be less than 1 for solid crystals, so it therefore has to be 1.958. Sorry. Now what kind of a crystal that could this be? I would leave that as an exercise to you guys. Check through the refractive indices of a lot of dielectrics or a lot of crystals. You will find something close to the value that you obtain.